Welcome, ladies and gentlemen, to the fourth of 5 web talks that we are broadcasting here from Dresden, from Saxonia, live with Uwe Kaltenborn together in the big testing hall of HIGHVOLT. Hello, Uwe.
Hello. Yeah, so we are back in the big testing hall here. Today we have something special in the background. What we can see there, so this is the background.
Oh yeah.
It's a lot of equipment there, but this is altogether a transformer test field for induced voltage testing up to 3000 MVA, which is a huge amount of power. And you have there also a highly precise loss power metering system, our LIMOS. So this is the most precise industrial available power metering system you can get.
And as you are the head of business development here at HIGHVOLT, you're always interested in these talks. We got a lot of feedback of the last 3 sessions. We have a live session today, every Wednesday at 5, and next week another one. Did you take any learnings already from the last 3 shows?
Yeah, some learnings, especially also that it's important also to take up all the questions. So we cannot answer all the questions, nevertheless. So please send the questions to us either via the chat function in YouTube or with the email address webtalk@highvolt.com. And there's a very clear promise from us. We will answer also the questions which are not answered during the broadcast here, during the live event here. So we will also do that afterwards.
So this is really an interactive format. Our topic today: will on-site testing technology replace factory testing? We are asking these questions, and to get a first impressions of the subject, we invite you to watch the following video showing modular DC test system and power transformer test systems. Yeah, and you could see in the video here very nice examples of on-site testing, factory testing, and now I'm happy and honored to present you our guests of today, the experts in this round. First of all, we are going to Zurich to Dr. Hans-Dieter Schlemper. He is Chief Engineer at Hitachi ABB Power Grids, and he received his PhD in electrical engineering at the Stuttgart University, and his promotion was about on-site partial discharge testing of GIS. And that's also his focus today, GIS. Hello, Mr. Schlemper.
Hello.
Great. Then we have with us live here in Dresden Dr. Alexander Winter. He is the regional sales manager at HIGHVOLT Prüftechnik here. He studied in Dresden. He continues his scientific career at the Institute of High Volt Engineers in Munich, my hometown, and he made his PhD. At HIGHVOLT, his responsibility is the Middle East, Americas, and parts of Europe as a sales manager. And Dr. Winter can refer to more than 50 scientific papers at international conferences, and of course he's member at IEEE. Hello, Mr. Winter.
Hello, and thank you.
So, and then we are live in Wolfenbüttel with Professor Jens Temper from the Faculty of Electrical Engineering Ostfalia, the University of Applied Science here. Mr. Temper is an active international power transformer standardization expert. He works a lot on there. His focus is the energy efficiency and the dry type transformer. He's head of development center for dry type transformer at ABB Brilon, Germany. He was there, and before he was at ABB Research Center in Switzerland. Hello, Mr. Tepper.
Hello, everybody.
Great. We start with Mr. Tepper in our round. As you know it already from the last sessions, we have a statement in the beginning, and so we go the round here to our experts. Mr. Tepper, on-site testing to verify the correct installation and condition of components and of a power system with interacting components is very useful. Contractual boundaries, legal conformity assessments have to be considered as well. Now, the question, considering transformers, what are the legal implications of the factory test?
One very important legal implication is, since a few years, the compliance of the transformer with an EU directive about energy performance of transformers. Since 2014, this is in force, and this is automatically also a law in Germany and in whole Europe. And we have Tier 1 requirements from 2015 on, and next year there will be the Tier 2 requirements. This means all power transformers that are in the scope of this regulation, and in Europe this is the majority, they need to fulfill those requirements. And major requirements are maximum no-load losses or maximum load losses, or a peak efficiency index, which is calculated out of that. And before you place a transformer on the market for the first time or make it available on the market for the first time, you have to comply. This means the manufacturer have to show the measurements and have to show that they match with this regulation. And then he has to provide a certificate, CE marking. Normally, you do this by applicate the harmonized standards in order to produce then a product, and this helps you then to presume conformity to the regulation. So it is highly important that before this process happens of making the product available, that you have done this measurement, this no load loss and load loss measurement, and that you then also, if you use the harmonized standard, that you follow the standard. So, and the question is now, what does it mean exactly making available or place a product on the market? And there we come into a kind of legal assessment. So I am not a lawyer, but I know that if you do the test in the factory, you measure the no-load loss and the load loss and calculate the PEI and do all the things that are required, you can provide the certificate, and then this is fine. I am also pretty sure that if there is the change in property, that the power transformer becomes the property of the customer, and you have not provided this, and you have not proved this, then there is an issue. So, and I'm honestly, I'm not sure if you are even allowed to transport a power transformer to a customer, even if it's not in the property of the customer, without proving this conformity. So this is a very important legal aspect. And then, I mean, there are other obvious legal aspects. If you would replace the factory routine tests by an on-site routine test, I mean, how should the manufacturer be sure that when the transformer leaves the factory, that really everything is as requested and is in accordance to the standard? And maybe something happens during the transport, maybe something happening during the commissioning on site. Then it's a question, who takes the liability? When did the property change? Those are the other aspects. But mainly I see also the aspect of this energy efficiency compliance.
So interesting that we not only have the engineer side, on also the legal side, bringing also this into our discussion. Of course, therefore, you can also ask your questions, what Professor Temper just mentioned. Certainly, there are questions popping up. Going to Alex Winter here in Dresden, on-site testing technology will offer much higher flexibility of near-identical testing conditions. But in the course of modularization, the difference between lab and on-site testing will fade, so melting into each other. How important are the on-site tests to prove the proper installation of the grid components?
Yeah. So that question is a little bit, or you can divide that question into two parts. The first part is the modularization and the flexibility of on-site test systems. So these kind of systems, they live with the modularization. So you have one system, and if you have a second one, you can connect it in parallel in order to achieve a higher testing current. And alternatively, you could connect it also in series connection, and then you can achieve a higher voltage. So that means especially these on-site test systems are highly modular in order to be available to go to different site conditions and to achieve the test power as well as the test conditions.
We have some pictures here, on-site test systems.
Yeah, exactly.
We saw some examples out of your daily work.
That's correct, yeah. So what we have seen is we had different systems for GIS testing, for transformers testing, for testing of cables. And so these systems are a little bit, they look different. But the main principle of being modular, this is the same for all the systems. So you can connect two transformer test systems to achieve a higher testing power. For bigger transformers, you can connect two cable test systems to achieve a higher testing power or even a higher testing voltage, to test extra high voltage cables, for example. And also these kind of modular systems, what you have seen, these modular reactors, they can be stacked on top of each other in order to achieve a higher testing voltage for GIS testing and so on. So that's the idea behind. And the second question, how important is it to have these systems for an on-site test? I mean, you have the factory test, and so the component is okay. So you have a test protocol, everything is in green light. Nevertheless, components will be assembled together, especially if we are talking about GIS or if we are talking about cables. Then the components, the single components which are tested in the factory are assembled together. And in order to prove that everything is assembled in a correct way, you need to test it again. And sometimes, especially if we are talking about cables, there are components which are manufactured or assembled at site and without any test in advance. For example, the joints between the cable lengths.
Okay.
You have cables on the drum, they are laid in the ground, and then they are connected by joints together. And these joints are not tested before.
Okay.
So that's why the whole system needs to be tested on site in order to prove that everything is installed correctly. And so that's the idea behind.
Okay. Going to Hans-Dieter Schlemper now with his first statement in this round today. It's our shortest statement actually, but certainly it's in the detail here. Assumptions never match reality. That's the statement of Hans-Dieter Schlemper. Assumptions never match reality. Mr. Schlemper, do you see the advantage of merging factory lab tests and on-site tests?
In GIS, merging of those two tests means either to do without the on-site test or to do without the routine test in the factory. And in GIS, it's a bit different than with other components that are shipped to site in one piece. Because a GIS consists of many modules, many shipping units, are tested in the factory individually, then transported to site, and then they are assembled on site to the entire GIS. And the site conditions vary. So sometimes we have very clean erection sites can be handled very nicely, where you don't have dirt, dust, or contaminants. But in some cases, we are working under harsh conditions, even outdoor. Need to make sure there that the assembly is done in a correct way. Both tests, routine tests and site tests, have different purposes. The routine test is to verify that the electron units are correctly working, that they are assembled correctly, and the site test verifies that transportation and installation is correct. So combining them would be easier if the GIS would be assembled in one piece and shipped to site in one piece, like a transformer. But at the moment, we rely on both tests. We even do more. We test modules or insulating materials with high voltage before assembling the shipping units.
Okay. Mr. Schlemper, just one thing. Could you perhaps speak a little bit up because we were like not too, yeah. I think now it's good just going a little bit closer to the microphone. So this was your statement to the advantage of merging factory lab tests and on-site tests. Another question to you. Failure costs, of course, are always critical along the value chain. The failure costs will increase maybe. If you have a problem in the beginning, then you take it over until the end. How critical is that for you?
Very critical, extremely critical. Because we need to detect failures very early in the production process. We usually calculate with a factor of 10 between the different test stages. So if you would have a number of monetary number for rectifying a problem with a insulating component at the beginning of the production chain, it would be multiplied by a factor of 10 while testing a complete shipping unit, and another factor of 10 if you need to rectify it on site. Because on site, you would need to disassemble the entire GIS. You would need to extract the faulty component and reassemble the GIS. And as this is a complex structure, it causes phases. Also, the time pressure on site is extreme. So a multi-stage testing process that captures the failures right at the beginning is very beneficial and important.
All right. Okay.
There is actually a country
of course, Mr.
that does it in the opposite way. And our colleagues in Japan, they assemble the GIS as a whole at the factory and tested, then the GIS is disassembled, packed, shipped to site, and erected on site, and it will be connected to the grid without any further high voltage testing.
Okay. Mr. Schlemper, just 1 second about the sound, because it's still pretty noisy, pretty rushy in the microphone. Maybe is another speaker in your computer activated that we hear you double.
We have an echo, so
if we could reduce the echo, but we got you until the end of your answer. Do you want to put something to your answer?
Okay.
Oh, it's much better.
Sound quality is much better now.
Absolutely. Excellent.
I didn't change anything, so.
Wonderful, but that's live. That's why. Just if you would repeat your last two sentences.
Yes. I was elaborating on the Japanese practice of assembling an entire GIS at the factory, test it there, then disassemble the GIS, carry it to site, erect it again, and it goes into service without any further high voltage test. So disassembly, shipment, and reassembly on site are processes that are controlled by our Japanese colleagues with very much diligence and detail, so that this process works. They are, I think, the only GIS manufacturers in the world that do without one of the tests. the site test that rely just on the routine test in the factory.
Great, excellent. Now we listen to you very perfect and clear, loud and crisp. Thank you very much. Alex Winter, it's always important to change the perspective. Of course, you always go in the perspective also of your clients and see what really they need when you're as a sales manager around the globe. Changing the perspective, so taking this into consideration, what will be the advantage to utilize identical equipment inside the factory or lab and on-site?
That could be given a very easy answer. It saves money.
It saves money.
Yeah, for sure.
Okay.
So you can use either the factory equipment and bring it on site to do the on-site test, or alternatively, it gives you some more flexibility in the factory if you have both an on-site test system and a factory test system. And if the on-site test system could be able to do also factory testing, in case of any malfunction of your factory test,
we have some numbers here.
Okay, I will explain that picture later on. Then you can even use the on-site test system in the factory in order to continue your production process and continue also the or to save your delivery times. If you look in that picture, you see a subsea cable, and this is another. On a ship.
Okay.
Yeah, and you see that drum is the same drum as in the factory. So the factory also the ship is in the near or in the place of the factory or this drum, and the whole drum of this cable, which is sometimes 80 kilometers, 100 kilometers long, is tested in the factory. And this is a new situation. In the past, it was only of a few kilometers. And then it has to be taken with a new drum, then a joint in between. And now the whole drum is tested in one piece.
Okay.
And in order to do that, the only way is to use the technology of on-site testing, where we already have these big lengths of cables, to use it in the factory. And the idea is to test these subsea cables not at 50 hertz, because this is not possible, so the testing energy would be too high. We test it at 10 hertz.
Okay.
The same testing frequency as we test subsea cables on site.
Because they're not cooled there on the ship?
On the ship it is cooled, so there's no issue with that. And so the testing energy is much less than at 50 hertz or 60 hertz. And so that gives the possibility to test the whole drum in one piece.
In one piece, okay. Yeah. And that saves time.
That saves time,
cost.
and then you can bring the drum by the vessel to the sea, and lay the cable in one piece.
Okay, excellent. Going with this question shortly to Mr. Schlemper, this changing of perspective. So, what would you say? Will it be an advantage to utilize identical equipment inside the factory or lab, or on site?
Of course, it would be an advantage if the equipment is flexible enough. And I prepared a couple of pictures of a typical test situation in the factory and on site. If you could maybe show these slides. Yes, maybe the slide before. Yes, I don't want to be a spoil sport, and it's an extreme example. It's about Sutong GIL, 1000 kV gas insulated line, which we constructed last year. And it is mounted in a tunnel underneath Yangtze River with a length of 5.4 kilometers. And next slide, please. And we use for routine testing a typical test set in the factory for the shipping units. Next slide, please. Which consists of a gas-insulated transformer and a gas-insulated lightning impulse generator. And these devices have comparably low power. They just need to test a section of maybe 20 meters of bus duct, but need to provide a high duty cycle, because we are running production in 3 shifts and this transformer is always on. more or less, with short interruptions to change from one test stock to the next. If you go to the next slide, site testing is something completely different. We test one single phase of this 5.4 kilometer GIL at once. You see here the resonant test set that is required to do that with 30 Henrys at 1200 kV, so a very large one that has high power but a very low duty cycle. And this is about typical for GIS manufacturing. In the factory, you need to test small sections of a GIS. On site, the sections can be very large. Like in a GIS in a dam, could be as long as 1 to 2 kilometers, or this is an extreme example with a GIL with 5 kilometers. So the flexibility for GIS testing must be extremely high, and I'm not sure if the current equipment has this flexibility.
Interesting. Thank you also for these pictures and for these insights, of course, which also goes into this discussion. And we are about halfway through our fourth web talk here live from Dresden. And I'm going to go over to Uwe because we are collecting questions via the chat, via email. Uwe, how we are doing today?
Yeah, so there is, as always, an ongoing chat discussion. So there's again some of the colleagues which have already found their partners for the discussion in the chat.
Great.
Nevertheless, I would like to elaborate a little bit on two topics. The first point which came in was, in general, all products should be passed the factory acceptance test before selling to the customer or handing over to the customer, as this is a legal requirement. So while on-site testing will replace factory testing, so the topic there we have already mentioned. Yes, there is some legal implications. Nevertheless, we have to look in which way we can tie in then also with this costly equipment to test that. Another topic, and I assume that this question is coming from someone more dedicated to medium voltage equipment. So maybe I'm wrong, but that's a discussion I can remember my time in the medium voltage business. So it could be also okay to have testing the first unit, then producing a lot of more units in the same process, and then it could be also acceptable that then the complete system, like a complete switchgear system of more panels, then to be tested on site. So maybe I would like to give the question back to Jens and Hans Dieter. In which way could that be also foreseeable on one end for distribution transformers? Jens, I know that you were very much involved into that. And is that also something which Hans Dieter already mentioned from the Japanese colleague of Hitachi ABB?
Maybe I start, or?
Yes,
Yeah,
please.
Yeah. Okay. So the chat says, okay, if we have a large quantity of, for example, distribution transformer, always with the same design. So could we only test one transformer and then, I mean, ship the rest and maybe test then on-site in the system? So first of all, we have to see, I mean, in the transformer business, the situation that you have one design and a large number of quantities happens mainly in this distribution field, where you have these small, I don't know, 250 kVA transformers, 20 kilovolt liquid immersed that you find on every corner in the distribution network. And there, I mean, you have maybe a typical design for a customer with a large number of units. But mostly in the other business, it's more like that you have a special design, or you have a design for each customer, for each request, and then maybe 1, 2, 3 transformer. This happens very often. So, and in this case, I mean, it's obviously that you cannot do something like this. And coming back to the large quantities, for this regulation topic, I would also not be in favor of this. And also, beside this regulation topic, I mean, there is always a certain risk that there were material issues, that maybe happened something during transport or whatever. So I would still recommend to do a routine test. Maybe one can do then less on-site if you feel safe. This might be, but yeah, that's my opinion.
Thanks. Going to Zurich to Mr. Schlemper.
I would like to revert to the initial statement, assumption never matches reality, because the routine test is also meant to prove that the process controls are in place and that the manufacturing process is stable. If I just assume that this is stable, I might get a failure afterwards. So this, in general, this option to deliver units that are manufactured in the same process, untested, relies on tight process control. And I think it would be feasible if the process control is adequate and if one can be sure through other means that the quality is constant. But currently in the high voltage business, we use routine testing as an additional means for process control. We see tiny variations in the failure rate, and we see it for certain components, and then we can react and correct the processes that might went wrong in the manufacturing of the last units. So it's an important quality assurance method also in our business to do the routine test and to feed back the findings per component with a proper analysis into the manufacturing process.
Thank you for your statement to this question. Uwe, the good thing is about our interactive format that people get connected in the chat and they answer their questions. But do you have other questions for our experts?
And I think I would like to hand over back to you for the next question, and would like to ask you to give me the chance to show a slide for the next question.
Absolutely, absolutely. But before then I go back to Mr. Temper for the question. And of course, while you're invited to activate or to take part in the chat and to write us emails, Professor Temper, for factory acceptance tests, special customer requirements are often to be fulfilled. Would it be possible to design a transformer or GIS outside of the common standards?
So if you say outside of a standard, then I would interpret it in a way that you do not mean better than the standard, but still fulfilling. But I would assume you mean I am in contradiction to the standard. And let's say technically you can design, but this is something I would strongly not recommend, because power transformer standards are also there in order to ensure a certain product safety. So every transformer that is energized on the grid should have passed the normatively required tests and the routine tests. So this is a must, to my opinion. And if you start to do something outside of the standard, there is a high risk that maybe your component is not fitting to the system where you attach it to. Of course, there might be less critical aspects. For example, in dry-type transformers, we have a quite low PD acceptance value. So we have in dry-type transformers the PD test as a routine test with 10 picocoulomb acceptance values. So, and I see this as a kind of quality measure that confirms that the production processes are good, because the transformer is designed to pass this test, and if you don't pass, there must happen something there. Mm-hmm. But qualitatively, I mean, some years ago we have 20 picocoulomb, and several years before we had 50 picocoulomb in the standards, and those transformers are still fine. So, and what I want to say is, there are some requirements that not necessarily lead to, let's say, an early failure. But on the other hand, if I have a transformer that was designed in accordance to meet this requirement and it is not matching this, then there was an issue before and you should have a look on it. So I would not recommend to design something out of the spec, also for liability reasons. And as I said, your product has to fit in the system.
Giving the question live to Uwe Kaltenborn here, responsible for the business development. What do you say?
Yeah, so I have prepared a slide that was the misunderstanding between the two of us, so can happen at the live session. So what I would like to address a little bit, when we look to different industries, so I have here two examples from our aircraft turbines as well as our compressors for the for pressurized air in factories. So they have this kind of performance contracting. So, and I ask myself, so in which way we might have in the future also transformers or GIS designed in accordance to internal rules of the manufacturers and selling by the transfer power in the power grid. So I know that this idea is not very new, but the question is, so if that works in other industries as a potential future development also for our industry.
Meaning pay-per-use then, or?
Yeah, so, yeah.
Should we give this question also to?
Sure.
Of course. In the round of experts, who wants to answer to this? Performance-based contract. Yes, please.
Yeah.
Shortly, and then Switzerland, and then Dresden.
Yeah. I would still keep my answer because, I mean, also if you sell the functionality, you have to ensure that the functionality is there. And if I sell the functionality to transform from 20 kilovolt to 400 volt in a distribution network, then there is still this network, and my transformer must safely work in this network. So also then the transformer shall fulfill the normatively required standards. And also if this is outside a grid, but in a factory somewhere, still, I mean, these standards represent also or are there for a certain product safety. So I still would follow the standards, also if I sell the functionality.
Thanks for your statement, Mr. Tepper. Now, Mr. Schlemper.
Yeah, I can only agree to that opinion because the standards make sense and usually they stack on top of each other. So if I have a customer-specific requirement that needs to be tested, it's usually on top of an international IEC, GB, checker. It makes sense also if I would own and operate equipment as an equipment manufacturer and just sell transfer power or something else, I can only do by using equipment that fulfills certain safety standards and certain basic requirements that makes it safe for operation in the grid. So I don't think that we can really change the product just by changing the ownership of the equipment.
Okay. Alex Winter, what about you? What would your customers say if you make this performance-based contract, if you offer them this? Or talk with them about it, discuss about it?
Yeah, I guess in principle it might happen or it might be possible, but nevertheless, if we are talking about the quality of the equipment, the quality check of the equipment, it changes the perspective a little bit because so the quality test or the final test of the equipment would be more or less for your own safety, for your own feeling that this system or the equipment is in good condition, and but it would not be anymore the contractual point. So contractually, you just have to ensure that the functionality is okay, and but how to realize this is your own responsibility. So that would be a change of the perspective. Nevertheless, in order to assure the quality of the equipment, you would have to do it by yourself.
Okay.
Yeah, and that's the same as manufacturer of HV test equipment as well as manufacturer of GIS or transformers.
Okay.
So I agree.
All right, Uwe, are you so far happy with these answers?
Yeah, I'm not happy with that. So,
Interesting.
but I think it's worthwhile from time to time to bring that topic up. What other industries are doing, and in which way we see their chances also for our industry to innovate. And maybe in 5 years from now, I will repeat the question, and maybe someone will have then a different answer to me.
But interesting to bring this also in these web talks, and because that makes it a little bit more spicy, and we try to, of course, bring also very new discussions up here, and also after the web talk you can ask your questions, and all the questions will be answered also then during the next days, and maybe yeah, we open more discussions, and in 5 years we meet again. Dr. Alex Winkler, of course, always interested in having the best solutions for your customers and selling the best products. Doing HV testing produces a lot of data condensed to information about the product. In which way such data can be utilized to improve the production process? Are you using this?
Yeah. In general, it's like collecting tons of data during the measurement of your test. If we are talking, for example, about transformers, distribution transformers, so we have the measurement of the no-load losses, the induced voltage, partial discharge measurement, and so on. And even the partial discharge measurement, so you have a criteria, maybe 10 picocoulomb, and so finally the result of the test is the transformer is okay, so the value is below 10 picocoulomb or it is higher than 10 picocoulomb, and then you have to repair it. Nevertheless, the collected data are much wider and much bigger, and you have PD patterns during the measurement, and that gives you some more information than just to have the criteria okay or not. So, and these data can be given back to the factory process, and you can influence the quality of your product by looking a little bit deeper in these measuring data. And that means that it is not just a simple test and a test result. So the idea is to give the production process some response for improvement of the quality. And secondly, if we still keep at the point of the transformers, distribution transformers nowadays are integrated in the whole production process. So that means, or testing of the distribution transformers. That means the transformer comes out of the production, then maybe the testing engineer takes a barcode scanner, scans the code of the transformer. The system in behind knows already, okay, these are the testing data. He has to connect the transformer once, and as we have seen in the teaser, and then the remaining process of testing with all the different test processes for induced voltage testing, no load losses testing, low voltage testing, and so on, is fully automated. So, and finally there's one result, so the transformer is okay. Then the next transformer comes out of the production and can be tested again. Nevertheless, the collected data are stored in the system, in the ERP system of the factory, and can be used for improvement of the production.
All right, so data collection is always an important thing, and
Absolutely.
you cannot, in a way, get enough data. This is also a topic that we can discuss more deeper, but going to Switzerland and to Wolfenbüttel. Uwe, please.
I'd like to jump in that because we had a very interesting question from the chat here.
Yeah.
So factory acceptance test values are also used for condition assessment, as measurements from on-site inspections are usually not available. Could this be solved? And I think this is what we have shown with the slide here, that we can integrate the data from the measurement system, so that could be on-site, that could be also the factory testing system, in a way that we can utilize these data then also for these condition assessments in future. And I think this is the big step forward, that we have then a continuity of the utilization of this data. And so as I always say, so data is nothing. We have to derive out of that information, because we only can deal with information. The pure sensor data will not help us. So nevertheless, collecting the information and having then also an open exchange standard, that would also help then to continue with these kind of data utilization in the future.
Okay. Great, thank you very much. Going now to Professor Jens Tepper. We have successfully, also to Alex Winter, so I'm asking first Mr. Tepper, we have successfully tested the individual grid components. What is about the importance of the system integration tests of the components?
Yeah, let's say sometimes you have special applications. Maybe in an industrial environment, you have multi-pulse transformers. There were current harmonics, voltage harmonics specified in advance. Sometimes your special application is operated in a certain way, so that maybe switching in the medium voltage happens quite often. So there might be some over voltages that could occur. So, and it is important that the system operates in a way that matches how the transformer was requested and how the transformer was designed. As I said, depending on the application, it can be very, very useful to verify that, for example, the harmonic content is as it was specified. Otherwise, I mean, the transformer could be overheated if you have too high current harmonics. Or I mean, we all know that switching transient overvoltages could occur. Yeah, the system aspect can be quite important.
Okay. System integration test of components, Alex?
Yeah. I gave the example already with the cables. So a part of the cable system, or a lot of parts of the cable systems, are consisting of joints. So connecting these cable parts, cable lengths together to one cable system, and these joints can be tested only at site. So they are not, they did not have been assembled in advance. So it's absolutely mandatory to make these on-site tests, and this is a complete system test.
Okay.
Yeah.
Uwe, do we have questions to this subject?
Yes, so we had certain questions which are related to the subjects, which were very interesting, dealing with a topic which we have not mentioned today. It was partial discharge. So we referred to the web talks before, because we had the web talks on partial discharge as well. So therefore, we would not like to take it up here. There was already some internal discussions in the chat. So therefore, I think it would be time to hand over to the three experts for the final statement.
Absolutely, and the good point that you mentioned the last sessions that we have. We are on the fourth web talk, in case you only connected to us right now, and we are in the last round. And of course, you can see and watch via our YouTube channel on HIGHVOLT.com the other shows also, and get connected and maybe discuss also about the subjects from the last Wednesdays when we had already 3 talks. So we're going in the round of final statements, starting with Professor Jens Tepper. Taking the topic down the road, can we even use the test data, we're talking about data right now, to improve the design of the products?
Yes, and
Yes.
I fully agree also, which was said by Dr. Winter. If we have the test data and bring it back to the production unit and to the design department, this can help to improve. As I said before, a big part of the transformer business is in a way that you have design rules and you design every time a new product, and then you have only a small repetition rate. So the design rules and the production processes are therefore very important, and having test data available is very important. And I can give maybe an obvious example that fits a little bit to my first statement to close the round. So we talked about this energy efficiency. And for example, we have maximum no-load losses are allowed. So it would be good to have a statistical evaluation of the no-load losses in order to evaluate how safe am I not to exceed this limit? How narrow am I? Do I have to change something? Is my supplier of the material reliable? So this is highly important. Then, and you can imagine if you are only 1 watt above the limit, you are out. You are not allowed to sell the transformer.
Hans-Dieter Schlemper, your answer to this, test data to improve the design of the products. And by the way, we see in the background in your office this wonderful flying globe, which is totally fascinating to me, nicely lit by the late Zurich sun. Thank you very much for this. Yeah, test data to improve design of products.
Yeah, we try that every day, I would say, because usually manufacturers these days, they have manufacturing execution systems that trace the components through manufacturing and also archive test data. That works well for the factories, but can also be extended to site tests, although there the process is mostly via paper. But the problem is that the evaluation of the test data is still manual work for the quality managers. So they need to sort the test data, they need to allocate it to different components and detect if a component has a higher failure rate than expected, or if a design has a higher failure rate than expected. And this usually triggers then an engineering change request to rectify the problem, either on the material side, on the supplier side, or on the design side in the R&D department. So any means in our digital world to simplify that analysis process would be very beneficial for us, to help the quality engineers to make sense out of that data. Data collection is not a problem these days. Data interpretation is cumbersome sometimes, but also very rewarding, because you can read a lot from that test data to improve the products.
Okay. Looking into the future, Dr. Alex Winter, would the combination of test data from routine tests, you have SAT, you have maybe monitoring data, allow to predict performance or lifetime equipment in the future? Is this a goal that you have, looking in the glass ball?
I wouldn't say predicting a lifetime, this is not really realistic from my point of view. But some assumption for the further life and for the further use and further operation of equipment, that should be possible as more data I collect.
Okay,
so if I have the routine test, so I have a fingerprint at a certain timestamp, and then I make the on-site test after installation. I have this next fingerprint and the next timestamp. And if I do some monitoring or retesting after some years or some months, then I have the next fingerprint. And I can compare these fingerprints.
During operation.
During operation. And I can see, is there any trend for maybe increasing PD value, showing that there's something wrong in your equipment. That could be especially for cables, but that could be also possible for the transformers. To have a retesting of the transformers, give you some more information, or a lot of more information for the operation, for the further operation, and some assumption for the lifetime of the transformer.
Okay. Great. We were discussing today, will on-site testing technology replace factory testing? Uwe, what is the take-home message of this 1 hour discussion? What is your stomach saying about it?
Yeah, so I'm absolutely happy that we have the 3 experts with us, really willing also to accepting this kind of very provoking web talk title. It was really also intended as a provocation. I think what we have to state finally is that today's product designs and product technology is still requiring HV, high voltage factory tests anyway, for legal reasons, but also for the implication of design and manufacturing. On the other hand, as transportation and installation is creating the highest stress, or maybe the highest stress in lifetime to grid components, the request for on-site testing is continuously increasing. That's something what we as HIGHVOLT experiencing over the last decades. So therefore, modularized test equipment suitable for both factory as well as on-site testing is for me an absolute technology trend. So here we see also there a very clear intention also to go on in this direction of modularization. Another trend is digitalization. We have talked about that, and here especially the utilization of the test data or information for process and design optimization will be key. There we are at the beginning of this journey, and that will be independent of test location as well as test concepts.
Okay, so also another very interesting discussion that we had today in our fourth web talk. And of course, ladies and gentlemen, there is another one next week at 5 p.m. We will be talking about super long DC cable links. Is it a chance or is it a risk? Of course, there we have another round of experts. For today, I say thank you to Hans-Dieter Schlemper. Thank you very much to your participation here in this talk, to Professor Jens Tepper also, and of course to Dr. Alex Winter here in Dresden, and to Dr. Uwe Kaltenborn. Thank you very much, ladies and gentlemen. This was our live session. And of course, gentlemen, in Wolfenbüttel and in Zurich, you got our famous Dresdner Frauenkirche in chocolate. As you know, all guests get this at the end of our session. In this time, we cannot present it to you live, but either you print it out with your 3D printer, chocolate printer, we say this every time, or we send it to you, but or we bring it live in the next weeks. So, this was the fourth HIGHVOLT Web Talk live from Dresden. Thank you very much for your participation, and looking forward, of course, to next week at 5 when we say hello again, and now we say goodbye from Dresden.